Now, there are some things that can go wrong with the experiments. Even if we have control, random assignment, and replication, there are still some things out of our control that we would need to account for. So, for example, the placebo effect is when a participant or experimental unit has a response to an inactive treatment. We can avoid by using a blinded study. Now, this just means that they respond even though nothing is going on. So essentially, they believed that it was happening, so it actually did happen. And I'm sure you've heard of a few effects of the placebo effect. Now, there are two types of blinding we can do to reduce this. The first one is called a single blind, where the subjects do not know which treatment they are receiving. So essentially, me as a researcher, I give everyone the same bottle, but in each of the bottles, I'm able to tell the differences in the treatments. Or I give everyone a pill that looks exactly the same, but I know that each of the pills has a different dosage. So that's a single blind, when the researcher knows, but the subjects do not know. Now, in a double blind, the subjects and the people interacting with the subjects do not know which treatment they are receiving. So me as the researcher and you as the experimental units or the subjects, we do not know which treatments are being dispersed. Now, that doesn't mean we just leave it completely up to chance. There might be a third party who is intervening for us to ensure the validity of our experiment. So, back to our example. Does caffeine affect pulse rate? Well, many students regularly consume caffeine to help them stay alert. Thus, it seems plausible that taking caffeine might increase an individual's pulse rate. Is that true? Well, one way to investigate this is to have 20 volunteers measure their pulse rates, drink some Coke, and measure their pulses again after 10 minutes and calculate the increase in pulse rate. So we're going to create an outline to see if this is a good experiment here. So when we create these outlines, we're essentially just giving the story here. So I have 20 volunteers, and notice that in an experiment, you're usually going to have volunteers, right? It's easier to recruit people who want to be in the study. So this isn't necessarily voluntary response bias. This is just like availability to you. Okay, actually, it kind of is like convenient sampling. Anywho, the point is we got 20 volunteers here that are going to participate. So I have my 20 volunteers right here. And in these 20, I need two groups. So I'm going to form two groups here. One group with 10 volunteers and another group with 10 volunteers. Now, I'm not going to ask who wants the Coke and who wants the Coke-free version, right? I am going to randomly assign them to get one of these. And so you can put a squiggly, or I think in the past what some of my students have done, just so they remember to go back, instead of a squiggly, they just write this giant R here. And this R is going to serve for our randomization method. So we want to ensure the treatment groups are as equal as possible, right? That's why I have 10 here and 10 here. So we're going to flip a coin to determine groups. Now, if tails, they get the caffeine group. Heads, they get the non-caffeine group. Now, I need to specify what happens, right? Because what if I end up with 19 tails and 1 head? Some of my groups are not equal. So I'm going to say repeat until a group of 10 is formed. All remaining participants will join the not yet completed group. So notice how specific I was there. Yes, we're going to flip a coin. If tails, caffeine. If heads, non-caffeine. Now, I can't just leave it at that because, again, what if I get all 20 heads or 20 tails or 20 heads? So then my groups are not balanced. So in order to ensure this balance, I'm going to repeat this until one group of 10 is formed. Once that group is formed, then all the remaining participants will join the other group that has not yet been completed. So when you're talking about your randomization method, we are expecting this much detail in what happens to ensure that your groups are as identical as possible. So I have my 20 volunteers. my randomization method, my two groups. Next, this group receives the caffeine group. This is my caffeinated beverage. Is that even how you spell caffeine? Caffeine? Okay, see, look. I definitely spelled caffeine wrong down below, so please forgive me, anyone watching this. But I'm going to call this one the caffeine group, and this one is the caffeine free. Now, once I do that, right, and I've just decided these treatments because I'm doing one with caffeine, so I'm going to give everyone a soda, right, whether it's got caffeine or it doesn't have caffeine, and then at the end, we're going to measure the pulse rates to see if there was an increase. Now, was there actually an increase, or did they believe there was an increase? So let's verify that each of my conditions here is met. So was there comparison? Comparison. Yep, because I have at least two groups. And so my baseline would be the caffeine free. So my base would be the caffeine free group. Now, so I have two groups. I could really put in more, right? I could put a placebo drink, a caffeine drink, or different doses of caffeine, etc. So at least comparison, I have these two groups to compare. The next one was the random assignment, and I was going to abbreviate that, but I decided not to. So I'm just going to say the random assignment, which is definitely verified here in this randomization process. So I've done my comparison. I have two groups or more. I have random assignment, and then the last condition was replication. Was there more than one experimental unit receiving a treatment? And it looks as though, yes, there were, because there were 10 volunteers in each group. So 10 vol per group. So I've met my three conditions for a well-designed experiment. Because this is a well-designed experiment, I, at the end, might be able to infer cause and effect here. Does caffeine actually cause this increase in pulse rates? However, even though it is well-designed, it could be better, right? Because I only have these two treatment groups. I could probably do different doses of caffeine or maybe a placebo group. But there's definitely ways to improve this experimental design.